Hi everyone, this is a follow-up to the Palindrome Linked List video. I was having a think about how to do this problem, and I think I have an idea on how to do it with truly order one space, not the, oh, it's in the call stack order in space that we did it last time. But it's a bit hacky because it actually destroys the linked list that we are given. So the idea that I'm thinking is we maintain two pointers effectively. The first one will progress one step and the second one will progress 2 steps every time until we get to the end of the list, or one of them gets to the end of the list. And the idea is what that will do is it will get us halfway along the list and to the end of the list. So that effectively tells us immediately where halfway is. But we're going to do something a bit sneaky as we're going along with that second slower pointer. We're going to flip these arrows around. 1 currently points to 2. We're going to make it so the 2 points to a 1. And what that means is when we get to halfway, we're going to effectively have 2 linked lists, one pointing back towards the start and one continuing to point to the end. Now obviously this has completely destroyed the linked list that we were past, so you'd never actually use this method, but it might get away with this here, with this constraint that we use order one space. So let's call this one race ahead. In fact, no, we can do this entirely within this function. So let's go fast head equals head. Bool is palindrome true. So let's start with this idea of racing just to the halfway mark. While fast head does not equal null, head is head next, fast head is head, fast head next. So if we're initially looking here, is this null? No, it's not. So this one goes here, the other one goes to here. Is this null? No, it's not. So this one goes here, and this one goes That's not quite far enough ahead, is it? How can we do this? I think fast head might need to start one ahead, doesn't it? So we've got this. So this is head, this is fast head. Then in the next round, this is head, this is fast head. And then in the final round, in fact, I need to do this in 2 steps, just in case. If fast head does not equal null, fast head equals fast head next. So at the end of this one, we've got one pointing here, and the other one is pointing off the end. So what I might do is I will put this condition in here. So we're initially starting with head, fast head. Fast head is going to step forward 1. It's still looking at something, so head is going to step forward. Fast step is going to head forward 1. It's still looking at something, so it's going to step ahead. So this is going to step forward as well. In fact, I might want to do another check. Head does not equal null. So this is basically trying to handle my odd even problem with checks. So here, head is here, fast head is here. Fast head steps forward. So that's that. So we're done here. So if we're doing this one, it's going to be head, fast head. Fast head steps forward, and it steps forward. So this goes here, it steps forward, it can't go any further, so it stops here. And if we had 1, 2, 3, we're initially going to have head and fast head. We're going to step fast head forward. It can do that. But is that what we want? It's not null, so we're going to step forward again. It is null, so we don't want to step this forward at all. So let me just write down this with the 1, 2, 3, 4. So we have head, fast head moves forward. It's not null, fast head moves forward. It's not null, so head moves forward. Fast head tries to move forward. It goes to null. So we're done. So this means we're always either... It's this condition here that tells us where we're at, isn't it? If we were able to do 2 steps, we went from here to here, that's fine. So we're starting at position 1. So if it starts there, if we can take 1 step, I think that's correct. So what we'll do is, first off, we will if is even length print puts is even, else puts is odd. So this obviously doesn't work. I just want to test it and see where we're at. Null undeclared. Oops, that needs to be capitalized. And I forgot semicolon. It's getting a bit late here, but I just had this idea and I wanted to check it. Is odd. Oops, I have these checks the wrong way around. So let's set that to false and that one to true. And I also want to try it with 1, 2, 3. So we correctly found is even is odd. Good, now we know how long it is and we know whether we're in an even length or not. The other thing we want to do is whenever we update the head, we want to do prev is the head. Struct list node start trailer is null. So this guy is going to go 1 behind this. We're going to go, and I also need somewhere to store the next thing, just as a temporary variable, basically. So I want to say the next is head next. Head next equals the previous thing is the trailer. The trailer gets set to the head and the head gets set to next. So this pointer update, what this does is it basically saves the 2 away. It says this points now to the thing that was before it. Oops. Thing that was before it, which is initially null. It then says the next thing you're going to point to is this. And then now I want to look here. So on the next one, it's going to say, well, remember to look here next. This should now point back here. And next time you're going to point to this. And now you're here. So that is the whole update. So now our linked list is going both directions. So when we finish in an even case, what we want to do is have basically 2 new list nodes. Oh, what we'll do is we'll reuse. How do we want to do this? We'll reuse next, I think. If is even length, we're in the case where these are our things here. Head next is head next. Otherwise, if we're in the odd case, oops, so what we want is to do next is head next. Prev is the, in fact, sorry, that's head next trailer. Head equals next. So what this does is, in the even case, all it does is it says, well, there's this other thing. In fact, no, I need to go further here. I need to say head next is the trailer. So we ended up here. We need to reverse this arrow effectively to that final step, and set the other value here to look like this. And in this case here, what we need to do is set this to be n, reverse this arrow, and move the head up to this same spot. So they're both sitting here. And then it's while next does not equal null. What we want to do is if head val, it was called val, wasn't it? Yeah. Does not equal next val, return false. Head is head next. Next is next. Next. So our head is going to walk backwards. Ooh. Yeah. Ooh, hang on. No, that's not quite right. In the odd case, I don't think we actually want to start them both here. I think we want to start the head back here and move the next along a wee bit, don't we? If next does not equal null, next is next. Next. Yeah, and then we don't want to make this change here. So, sorry, the even case stands. The even case was next is head next. We look here, we set this to be the next thing, and then we just make sure head.next gets set to trailer, so we turn this arrow around. That ends up looking like that. So then they're both going to walk out one step at a time. In the odd case, we start here, we say next is head next, so this is next. And then if we can, which we should be able to given its odd length, that's fine. In fact, I'm going to do one last check up here. If head next, so this is just the case of one. If the linked list is just a singleton, and then I'm going to return true, just for simplicity's sake. So then that saves some of the checks down here. Head val doesn't equal next. If next is not null, which should always be true, we're going to step this forward again to be here, and we're going to reverse this pointer here. So actually, let's try this with 5. 4, 5. So we're going to start with head and next. So we're going to do this loop, fast. If fast is not null, fast moves forward. Then can I shrink this? Almost enough. Yep. Fast is not null, so fast is still not null, so we move it forward again. Fast is still not null, so we're going to move the head forward by 1 and reverse the arrow. Then what we're going to do is we're going to go around again. We're going to move forward by 1. It's not null. We're going to move it forward again by 1. It is null. So we're going to stop. And then we go into this check here. We've decided it is odd length. So in here for the odd length, next is going to get set to this thing. Head next, and get set to, sorry, no, this one here. If next is not null, we're going to step forward again, which we can do. Head next equals trailer. Well, that was already set, basically, so I think that should be fine. In fact, that's always going to be true, isn't it? I don't think we need to redo that update, because if we have a go at the even one again, we're going to do head and fast. Initially these are pointing forward. We're going to move the fast one forward. It's not null. We're going to move the fast one forward. It's not null. So we're going to move the head forward and reverse the arrow behind it. We're now going to try and move the head forward. It's null, so it's an even length. We're going to stop there. The next is going to be set to this thing. Excellent. So now what we have is we have the head and the next on both sides of the middle. If it's odd length, we never check the middle thing. We don't care what it is. It's fine. If it's even length, we have both of the middle things selected, basically. And then we just go through. While we've still got somewhere to walk, we're going to walk through both of these linked lists and check that they all have the same value. Whew. I think that works. Let's test it. Wrong. Why is the first one wrong? Printf %d %d new line. I want head val next val. Show me everything. Okay. Let's actually reinsert this check. Oops, with semicolons. Obviously this isn't quite doing what I thought it was. Yeah, that's better. Right, I was setting things in a different place to what I expected. So if I have 1, 2, 3, 4, 5, 4, 3, 2, 1, that should also succeed. Yes, it does. Okay. So that now only allocates these 5 things. That's constant memory. It doesn't use recursion, so it's not using the call stack to sneak in some extra memory. And it does it in order n time because it effectively walks half the list and then walks the other half of the list back again. So that's our order n usage. Let's submit it. Perfect. So that used much less memory. Speed-wise, it's basically the same. I suspect all solutions are coming in at around this. Speed, because it's pretty fast, will be middle of the pack there. This is good. We're using much less memory, although we're not using considerably less than we were before. Probably because the vast majority of the memory is actually all of the linked lists that were being passed for the problem or test runner overhead. So although it doesn't show up here, we have actually made a more memory efficient algorithm. And it is also probably a wee bit more efficient in terms of length, in the sense that in terms of speed, in the sense that we don't have to deal with all of the function call overhead that even in C is present. Right, so that was this little extra. Hope you found this enjoyable. Thank you very much. Remember to like, subscribe, comment, all that good stuff. And a quick channel update. I will hopefully upload tomorrow as well. It'll be a busy day, but I should be able to find time. But Thursday and Friday, probably not. Work is absolutely piling up at the moment. So anyway, see you all next time. Bye.